All right, so now we're going to we talked about translating or moving, shifting to the left, to the right, and so on and so forth. Now we're going to talk about what happens if I want to reflect. So looking at this, if I have f of x equals x squared, and actually let's make our cameras a little bit more centered there. If I have f of x equals x squared, then if I wanted to flip it over the x-axis, then I'm going to have negative x squared. Y'all follow me so far? So we got negative x squared. All right. So if let's say that I wanted to shift to the right too. All right. So let's say I wanted to shift to the right too. I want to shift to the right too. Well, how would I do that? Well, let's remember we've got x minus h squared plus k. Well, if I'm shifting to the right, I don't care about the k part. And if I'm shift to the right too, that's going to be x minus 2 squared. So let's go ahead and put it into our decimals. We're going to have x minus 2, and then we're going to square that. All right, and boom, as we can see, we've shifted to the right too. All right, so we shifted to the right too. What if I want to shift to the right too, and I also want to reflect over x-axis? I want to reflect over the x-axis. Well, I put a negative in front of the parentheses, like that. All right? Negative x minus 2 squared. Now, what if I wanted to, instead of reflect over the x-axis, wanted to reflect over the y-axis? Simple. I would put a negative in front of the x term, like this. So now I have reflected over the y-axis. What do I want to reflect over the y-axis and over the x-axis? Well, I put a negative in front and a negative over there, and if I do that, it will look something like this. So what have we learned from all this? Well, basically, we know that if you have f of x equals x minus h squared plus k, remember that's our vertex formula, then g of x equals negative x minus h squared plus k reflects over the x-axis, and h of x equals negative x minus h squared plus k reflects over y-axis. So let's do some examples. Let's do some problems using this stuff. So let's say that I wanted to, let's say I wanted to go to the left, okay, I can't write, left, 4, up, 2, and reflect over the x-axis. All right, I'm going to go left, 4, up, 2, and reflect over the x-axis. So what you would think to do is, okay, I'm going to do x minus 4, we're going to go up 2, that's squared, and put a negative in front of it. Well, notice I'm not actually, I'm going to drag this over here. I'm not actually reflecting over the x-axis inline. I'm just opening down versus opening up. So what would be better to say is here, when it's positive, we're opening up. When it's negative, as you can see, we're opening down. So how could I reflect this thing over the entire thing? How could I reflect this over the x-axis rather than just opening down? Well, in that case, I would have to reflect over the whole thing. So that's why I'm adding this extra parenthesis here. But over here, I'm going to put brackets. So if I went to the left 4, up 2, and reflected over the axis, that would be negative brackets x minus 4 squared plus 2. Why? Well, it all goes back to something called PEMDAS. Y'all remember that? Where we got the order of operations. What this says is I need to make my translations first, then reflect. So I need to do all of this stuff inside the parentheses first, then reflect. What if I said I wanted to reflect, then go left 4 and up 2? Well, then that would be negative x minus 4 squared plus 2 without the parentheses, which I will now graph. X minus 4 squared plus 2. And notice the difference here. Here, basically what I did is I reflected first. Okay. Then I translated over to the, oh, it's supposed to be going left. I just noticed that. Oops. This needs to be plus. This needs to be plus. My bad. I'm so sorry, guys. Plus, I mean, here's to say. Well, you get the gist of it. I'm going to the left, 1, 2, 3, 4. And then I'm going up 2. So that's this one right here. In other words, I reflected first, and I've translated over to the left, or then up 2. So in other words, the vertex here is going to be, so for the vertex for this one is going to be 4, negative 4, 2, right? Negative 4, 2, because I translated over 4 to the left and up 2. Now, what is the vertex on this one? Obviously, we can look at it. It's negative 4, negative 2. Why is it negative 2? Well, because if you multiply this negative out, what this really is negative. Notice the negative 4 doesn't change. It's negative 4 on both of these, right? That doesn't get affected. But your y value does, because this negative, if I distribute this out, this becomes negative 2. All right, let's do one more example just to bring it all home. So what if I tell you, I want you to translate 4 up, 3 to the right, and open down. 4 up, 3 right, open down. Well, let's do it. 4 up. I know there's going to be a plus 4 on the outside. And I'm going to open down, so I know there's going to be a negative out there. So we're going to have x minus 3, because I'm going to the right, squared, plus 4. Now let's graph it and see where I'm right. If I'm not, this is going to be messed up. All right, so we got negative x minus 3 squared plus 4. Let's see if everything is right. So my vertex, 3, 4, right? I went up 4, that's before. I went to the right 3, so yeah, that's right. and I'm opening downwards. So boom, that's it. Real simple. Let's do one more just to practice. What if I tell you I want to go left 2, down 1, and open up. I want to open up. Well, that's just going to be x plus 2. Remember, it's inverse, so I'm going to go to the left, so it needs to be plus 2, and then down 1. And since it opens up, I don't need a negative in front of this. So let me graph that right down. So x plus 2, and then minus 1. This is supposed to be 2. So let's see. I went to the left 2. Did it? Went down 1, and I'm opening up. And that's it.